Okay, so welcome to the LMG Lightning Talks session. Apparently we've just decided that I should go first. So I am Vero, I'm a Linaro employee working from Switzerland. One of the last bigger projects I'm more or less finished is getting AOSP to build with Clang 3.6 and Linaro GCC 4.9 and GCC 5.0 pre-release. The status of those patches is they've all been submitted upstream. It's around 200 patches that were needed, mostly really fixing bad code instead of having to work around compiler bugs. The only things that are still outstanding are 2 patches that are needed for GCC 5 only. Apparently Google doesn't really look into that yet. We've run a couple of benchmarks, and the difference in performance and binary size is actually quite small, much smaller than we expected. Typically GCC is a little bit faster, but there's still other reasons why we'd want to possibly use Clang 3.6 or why we'd want to update to GCC 5, such as supporting newer standards of languages like C++ 14, or just getting better error messages or getting more warnings. Like some of the things we had to fix to make the code compile with Clang was clearly caused by bugs that were there but just unnoticed in the GCC world. So, okay, something didn't go quite right with the format conversion, but I think it's still quite readable. This is some actual numbers. The full results can be seen on wiki.linaro.org. On the Nexus 10 you can see,
I'll fix it.
okay, just a second. Okay, can you go back one? Yeah. Okay, you can see the numbers overall are pretty similar. Typically the GCC builds are slightly ahead of the Clang builds, but no huge differences anywhere. This is in the ARMv7 world on the Nexus 10, and on ARMv8 on the Nexus 9. It actually looks similar, except Clang generates better code there. Caffeine Mark actually has Clang ahead. Anti-Mark native is really close. CF Bench is close. In Smart Bench, the Clang build actually is better in office performance, while GCC is slightly better in gaming performance. Binary size as well. On ARMv7, GCC binaries are a little smaller. On ARMv8, the Clang builds are a little smaller, but it's always only around 2 or 3%, so no big differences. So things we still have to do on this project is make sure Upstream doesn't break Clang support again by committing new code that introduces more compiler errors. We're going to do that by running daily builds and fixing stuff immediately as we see it breaking. Then we have to upstream the remaining 2 GCC 5 patches. We'd really like to automate benchmarking some more and determine if Clang builds can be optimized with some additional compiler flags. Right now we just use stock compiler flags, which are typically optimized more for GCC than for Clang. Clang has optimizations like -OZ that optimize even more for size over performance than the -OS, which might be interesting for some lower end systems where we are short on memory. That might be worth another try. Yeah, okay. We don't have a lot of time, so if there's any quick questions, I can answer. If not, let's move on to the next person. Okay.
No questions?
It is said that the next major release of Android is going to using the clang built for the whole system and carried over GCC. Is that have you heard that, or do you know this?
We don't know whether or not it's true. We've heard the rumor, but we've heard the rumor before the Android 5 release as well. So I think they are talking about it internally, and it might or might not happen. They're definitely interested in taking the patches these days. They've all been accepted now, and we'll have to see where they take it from there. Anything else? Okay, who's next?
Okay, so Emmett, do you want to just mention a few things and maybe answer a few questions about where things are with the Android upstreaming?
Sure, I can talk about the patches which I've been working on, and maybe Daniel can take on the
Go for it.
set of patches. Because I don't have any slides prepared because I just got to know that I have to speak. Okay.
Yeah, we were expecting John Stoltz to be here, but that's the way it goes. So go ahead, Emmett. You'll do fine.
Yeah. First set of patches I was working on was related to PM debug patches. These are the patches which are present in Android, and they mostly print the debug messages related to suspend resume state. So there are three sets of patches. One was there is something called PM suspend log. So what they do is they log the reason why the system did not go to the suspend state in the first state in the first stage. So when I tried to upstream it, I got to know that Google is working on doing the same thing, but in a more upstream friendly manner. So that's what we got to know from people working within Google. So we dropped that idea of doing it ourselves. Second set of patches was again printing some debug information. I sent the patch upstream, and I got to know that the same functionality can be achieved using tracing tools. So that's all I can do about that patch. Third patch, I vaguely remember what that was about, but it was the same thing, that I was trying to do something and it can be done using the upstream tools which are already available in the Linux kernel. So PM debug patches, I was not able to upstream any of those three patches. Second set of patches I was working on was related to config-fs, using Android USB gadgets, trying to make Android USB gadgets working with config-fs. It was quite an interesting one. As we all know that John published a blog, how to use ADB using function-fs and other things. So ADB support is already there. I did not have to do anything, and it works straight away. I was talking to one guy in Google, and he's saying he told me that Google himself is working on implementing this in using config-fs. So they are also moving away from composite driver and trying to do that using config-fs. So he has already pushed a couple of patches for MTP, PTP, and one more thing for RNDIS in 3.14 kernel. So I helped him validating those patches and that it works fine for Lollipop and 4.4. So in those set of patches, my role was limited to providing feedback, and I did provided one fix, but it was related to 3.14 kernel, not the upstream kernel. I checked him whether he has any plans of upstreaming it, and he told me that once they have everything in place, they will actually upstream it. So right now, that's the state it is in. That's all I've got.
All right. Thanks much, Emma. Any questions? All right, we'll move on to the next thing.
I can say about ADF if you want.
Yeah, actually, if you would, Daniel, that'd be awesome.
I've been working two things, but the Fick debugger has a whole presentation tomorrow, So I'm not going to talk about that here if you want to learn about Wednesday, sorry. But ADF is another thing that has been worked on, and it's not grown fruit, and unfortunately we're then going to have to pause the work for a while. But the state it reached is, when you look at ADF and you compare it to DRM, it's very evident that you want to have a system where you can run both, so that you can really get the feel of what you're doing. And there are no current platforms that make that easy. So ADF has a big pile of upfront work you have to do before you can actually start working on ADF, and some of that work still remains. So you have to find a platform that has appropriate DRM drivers to make it possible. The only one we could find was the Qualcomm platform. And then when you've got that platform, you have to get a port of ASP running on it, which we have also done, which wasn't that hard. We took the stuff from the Builds and Baselines team and ported it to a new SOC. That was quite easy. But the third thing then is you have to get 3D accelerated graphics going, and that hasn't been achieved yet. There's a chance we can get it done with the drivers from Rob Clark, the Freedreno stuff, but we haven't, or I haven't yet been able to bring that all together to create that baseline development platform to actually kick off all the work from. And I'm not sure that's resource straightforward yet.
I don't think it is.
Yeah, so that's going to pause at this point. I'm going to park the port in repos and Git so that we can dust it off. But until the next lot of resources come, that's now parked for a while.
Comments, questions? Thanks much. Really appreciate you. Impromptu speeches. Okay, so this next one, Smeet Semwal would normally be presenting this, but he's at a Google event this week, so he's not able to be here. So I'm kind of the stand-in speaker, which means if you ask me any questions whatsoever, I'm just going to say I don't know, because that's probably going to be the most accurate answer. So what this is all about is something Smeet has been working on for cenalloc, which is a user space API, which is going to kind of sit on top of and a constraint aware allocator. And this work got started about a year ago, and really what it's all about is taking a number of Ion features and getting it upstream. And so this started out at Macau. Ion has been in staging for quite a while now, but there's a number of difficulties that are associated kind of with it. And so kind of the point of this presentation is just kind of give you a little bit of an update of where things currently stand today. Okay, so there's been an RFC that's been posted. It's gotten some comments and feedback and all that, and direction as far as where the design should go. So if you haven't seen the LKML RFC, by all means, that's something that's worthwhile going and following up on. So with regards to the comments that did come back, it sort of split up into a couple of different camps, and so that's constraint sharing, helpers, and it kind of was interesting. So there's gone through, and now we're up to sort of version 3 of the patches right now, and so there's still some objections / feedback that's sort of outstanding that I know Smeet's trying to work through and get some consensus in the community as far as getting people on board and accepting what he's proposed in code. So between Russell and Daniel and Smeet and others, it's still a work in progress, and I'm sure the design is going to evolve as a result of that. Nonetheless, there is code out there if you want to go take a look at it. He hasn't posted the next version of the helpers, but I think he's going to do that again fairly soon, at least as far as as soon as this issue gets worked through. So next step wise, again, it's all just kind of acting on the comments of the community and working with the people that have been kind of posting concerns or objections, and making changes if again you can get to some consensus. So that's kind of where things are at. I think that's the last slide. Yeah, that's it. So I don't know, any questions that are really, really easy. Okay, so
is Ion like a backend allocator for cenalloc? I mean, is cenalloc like a framework, and these allocators just plug into that one?
so he's actually using DMA buff
Okay.
on the back end. And so, like, you know, there's a number of people that are looking at cenalloc for, you know, as users of it. So
I think
like
there was talk of having,
Gills.
I think there was talk of having ion allocators
Yeah.
maybe plug in
Okay.
do that, but
Yeah.
with all the community feedback, it looks like things are changing.
So the patch set there was to do with when you want to map a DMA buff, it was the capacity to say, I have a constraint in the mapping you must give me. Classically, I need to be physically contiguous, or I need to get my IOMMU right. And the reason for all the feedback was it was difficult if two people map at different points in time, and the latter one is more constrained. It's too late to update the mapping, which is what all the feedback's about.
Any other comments, questions? All right, so that's all that we have on that topic. And I'm not seeing, there was one other. Oh. Yes, please, go ahead.
Okay, good afternoon, everyone. I am in Shenzhen. My friend like call me Peter because my last name, and I am an assignee from MediaTek Taiwan. So today I want to talk about what I've done during the past 2 months. The memory footprint analysis. This topic will cover. First goal is to find out the minimal requirement for 64-bit Android with a Full HD display. Then we tried various well-known memory optimization to see if they are useful or not to improve the memory usage and reduce the memory usage and improve the user experience. Alright, this table shows the memory usage after the Android boot under different memory size. As you can see very obviously, the used memory size is very similar no matter the memory, how much the memory. And in 768 megabyte this case, the memory free is less than 100 megabyte, which will cause to the low memory killer trigger very often, and that will apparently hurt the user experience. So, alright, I think, in my opinion, with 1 gigabyte is a better choice for the end user product. Then we tried various memory optimization methods to see if they are useful or not. First is swap. I created about 200 megabyte swap file. But I found that the low memory killer still try to kill apps even the swap area is available. I mean the usage of the swap is very low, around 5 or 6 only 5 or 6 megabyte only. And I also try to set up the swapness, but it seems like it does not solve this problem. Alright, the second one is ZRAM. ZRAM use the compressed memory to for swap area. So it also encounter the same problem as the swapper. Yeah. Then the third one is KSM. KSM try to find out the memory pages which have the identical content and try to merge them. But in Android, it only saves less than 10 megabytes only. So I don't think KSM will have a significant improvement here. Yeah.
What is KSM, I'm sorry?
KSM?
Yeah.
KSM try
Same page.
kernel same page module. Yeah. You will try to find out the page have identical content and merge them into one page. Alright. However, I found that around 200 megabyte caches can be freed by this comment. Which means that we can after boot if you free the 200 megabyte, then yeah, you can get 200 megabyte free memory. That will make the low memory killer not get up so early. Yeah. And so my conclusion is that among these three well-known memory optimization methods, they seems like very helpful. But at least I found that a large portion cache can be freed, which may be kind of useful for Android device with very low memory size, and maybe we can come out some idea that make the cache flush policy can work with the low memory killer, and to make the memory management more efficient. I guess. Yes, that's all. Any comments or questions? Yes.
So there's no possible method to reduce the memory footprint in Android 5.0 version?
You mean a tool like can probe the memory usage, or?
No, I mean, is there any helpful method to reduce the footprint?
To reduce
reduce.
Yeah, maybe there are some other, but yeah, maybe there are some other I don't know, so I have not yet tried. I mean, I just as I read the Android website, there is a section talk about low memory. You mean how to tune your Android device under low memory situation? And in that page, they also provide those three methods. So I start from these three methods.
I don't know whether other guys has some ideas why the iPhones use 1 gigabyte to do the full HD, but for the Android, 2 gigabyte also not very good. I think this is LMG group will need to do something about the situation.
Yeah, there's a next layer of the onion here. I mean, this is really the very first outer layer, and you're right. You know, now we're really down to that. Okay, we have to take apart all the various components of the system, and seeing, you know, can we bump some memory here? Can we bump some memory here? And that's a very long, potentially very difficult thing to do. You know, and just kind of in general, you know, there's certainly some concern about Java, and it's, you know, it can be a bit of a memory pig.
And
you know,
when I read all the patches that was in AOSP master branch, and there are lots of art
Yeah.
patches
Oh, yeah.
which will reduce the footprint. And that would be some ways to reduce the
Yeah.
footprint of that.
Yeah, so, you know, all this together, I don't think there's one easy answer. It's going to be lots of little things that get us there over time, and that's, you know, that's just kind of unfortunate. And, you know, you think about, well, the next development cycle, let's hope that it doesn't get put off till then to, you know, put Android on a bit of a diet and reduce the memory footprint. I hope that's not the case, but, you know, it's, you know, this isn't a matter of next week we're gonna have something. It's gonna take a little longer than that, which is, you know, not what we wanna hear.
And actually, there's a pretty good chance that at least some of that memory usage is applications caching stuff internally, like art caching some pre-generated binary code, then it will run again. Maybe there's some room for just tweaking how much those applications cache. But that all needs to be further investigated.
So is there a particular use case for this? Surely most people are trying to reduce the memory still on Android 32. They're doing low-cost devices.
That's exactly the use case. It's the low
trying
end.
to move people, the low-cost devices, to 64-bit. Because obviously you're going to save a lot of memory by being 32-bit.
Yeah.
Easiest way at the moment.
Well, yeah.
Sorry. Yeah, I'm just interested why push so hard at the moment.
Well, you know, is you know, it's for others to decide, you know, sort of what the future is for a low-cost device, and does that always stay 32-bit, or does it go, you know, 64-bit at some point? It, you know, I'm not going to make any conjectures as far as what might happen there.
But everyone knows 64 is twice as good as 32.
Oh, absolutely.
And therefore they'll have to go that way for marketing and nothing else.
Yeah, I'm just trying to work out whether this is people trying to get the speed of 64 with the memory footprint to 32 in some magical way.
Yeah.
So,
All right, thank you, Peter.
thank you.
Any other comments,
Yeah.
questions?
Xavier is still learning about compiler flags.
Yep. If you want to sit here. Lord.
Thanks for everyone to attend today's lightning talk. I'm Xiangyu Shi. I'm working at Fujitsu. In this session, I will introduce some GCG flag for improving our system's performance. The topic one I will use try to modify the GC optimization option flag like O3, OS, and Ofast. The type 2 I will remove the global Android makefile GC flag, no tree aliasing. In compile time, we were doing some errors, so we will add no tree aliasing in the local makefile. In our experiment, I used the Android Lollipop and runs on the Nexus 10. The green color test means the result is better than the original setting. The red color test means the result is not better than the original setting. According to the table, we can know if we choose the OS flag, the size of image will better than the original setting. And in memory usage testing, I measure the memory usage 2 times. The before means I measure the memory usage when I first boot the system after refresh it. The after means I measure the memory usage after I using some Android apps just like the browser, the camera, the YouTube, and play some videos. If we use the O3 flag, the memory, if we choose the O3 flag, the memory usage is not better than the original setting, other will better than original setting. We use some the benchmark to measuring the system performance. According to the table, we can know if we use the Ofast flag, the benchmark will better than the original setting. In this topic, we remove node 3 aliasing flag in global makefile and add node 3 aliasing flag in the local makefile. According to the table, we can know the size of image are the same, but the memory usage was better than the original setting. We also use some benchmark for testing the system performance. According to the table, we can know some native result here are acceptable, but the others benchmark will for testing our system is better than the original setting.
So, quick question: the benchmarks, is it like one reading you took, or is it an average number? Because I don't see like more than 2 or 3% difference in some of the benchmark data. Usually these benchmarks, there is always a like 5% error when you're making multiple measurements. Is this a one reading data, or it's like on an average 5 reading data?
In our
Especially quadrant, when we do benchmarking, we always see like it's never that particular number. And when I see the data here, like for example quadrant pro, it shows 2012, and when you made some changes, it's 2016, which is significantly less. How are you proving whether it's actually improved or not?
Your question is you think the data is not bigger, right?
Yeah. So the difference in the data optimization, it's like less than 1% difference. And without using the change of these flags, did you see like quadrant pro, was it showing always like the 2012 data always, and after using the flag, did you see the data always as 2016? Is that something which you considered while making the benchmark data? What is the sampling rate of your benchmark?
In our experiment, I measure 3 times and equal the data. 3 times, yeah. But I'm not sure. I think maybe the data is not big. Yeah. So we just this is to testing. Yeah. And I also have some detail, but I did not put on my report.
Yeah, and there are some random fluctuations in there, because -f no strict aliasing is a workaround for bugs in code that cannot possibly result in better code being generated. So anything that shows up in red here is a random fluctuation. Those numbers should actually be the same or slightly better than with global -f no strict aliasing, but those fluctuations happen, and even if you run a benchmark 10 times, you'll probably run into a few of those. benchmarks are just not 100% reliable. But where there's actually a big difference, like in the CF bench, Java score and overall score, there's a pretty good chance that it's a real improvement.
In topic 1, we can use the OS or Ofast GC flag depends on we want to improve our memory usage or the system performance. In tab 2, the memory usage and the system performance will be better. So, when we remove the no-string aliasing in global makefile and add this flag in the local makefile. So in our plan, we will upstreaming the patch for doing this. Yeah, that's so. Everyone has some comment or some question.
Are there any stability issues about these flags after you using it?
The
stability issues.
Stability.
Did you run into any crashes or any applications giving wrong output or anything?
Probably check
So, as far as I know, there were no stability issues, because if there had been any, chances are we would know.
And the patch you said, are you going to submit to AOSP or to be something Linaro wants to carry over?
We're going to submit them upstream. I mean, obviously this only goes for the -f no strict aliasing removal, because there's no clear winner between -02 and -0s, -0fast. That really depends on whether you're optimizing for memory usage or speed or something in between. And so upstreaming any change there doesn't really make sense, but documenting what kind of effect you can get by using them does.
So in a case like Java score improving with no strict aliasing, I guess for that particular project the flag will be overridden or something like that you submit upstream?
Yes.
Okay.
So the entire -f no strict aliasing thing is -f no strict aliasing is workaround for code that violates aliasing rules that are not that the code isn't supposed to violate according to the C standard, but a lot of code does violate it. And Android currently works around this globally by introducing -f no strict aliasing everywhere. And the project here removed the global thing and identified code where it's actually needed and just put it there. So in most of the code it's not actually needed, and flag can be removed safely. And there's just a couple of locations where it has to be used, and there it goes into local makefiles. And obviously we could go a step further and just fix the code so it wouldn't be needed at all, but probably given the small effect it has, that's not really worth doing.
So, Ofast appeared to give a memory benefit and a performance benefit. Did I read the slides correctly? So the one of previous file showed previous slide showed memory improvement in it.
Yeah, go back one.
I'm colourblind, I find it hard to see, but yeah, so you're seeing better RAM usage with Ofast because of the standards relaxation. Do you kind of think Ofast is something you put on a whole system or something you put on a project because it is a standards relaxation?
We didn't see any drawbacks from using it, but obviously there might be some code that has hidden consequences in it. So it's something to play around with, but also to be a little careful with.
Yeah, because it's a clear win. It's much better memory and it's faster. So.
The actual difference in memory is quite small, but okay, at least in the after boot up, but after the rest is actually better. So it's probably worth doing some more testing with systems,
I mean, it's
and
a very-
especially running CTS on a system that has
Well,
been compiled fully with it.
Because it is a very striking benefit, very striking.
And also we need to repeat this exercise once GCC 5 is released, because things might look different there.
What's it? Any other comments, questions? Thank you, Xavier. All right, I think we're about out of time, so thanks much for joining us for these LMG lightning talks. Appreciate it.